वेलकम टू प्रैक्टिकली वी ब्रिंग लर्निंग अलाइव। और आज हम कर रहे हैं हिंदी में नहीं कर रहे हैं ना, इंग्लिश में। सो टर्म 2 के 5 मोस्ट इंपॉर्टेंट क्वेश्चन की सीरीज है और एक दिन पहले आ गई है ये वाला हम पहले कर रहे हैं, मैग्नेटिक इफेक्ट्स ऑफ इलेक्ट्रिक करंट। इसमें हम 5 क्वेश्चन करते हैं, सो वी डू 5 क्वेश्चन इन दिस। हर चैप्टर का वी आर डूइंग एवरी चैप्टर। आई डोंट नो हिंदी क्यों आ रही है इतनी। And we are going to solve only 5 which are relatable to your own term 2 के relevant. So these questions are relevant to the term 2 exam, and these questions have more weightage or they have come like much more time than the other questions. Like these have been occurred a lot of times in the previous board exams. Fine. So what we are going to do now, we are going to solve these 5 questions. We have already covered all the other chapters. So this is the last physics chapter. So I have taken a one day, leap, and I am solving rather than tomorrow. I am solving it today, so that these things can be finished easily and faster. So tomorrow math, last one session on math will be finished, and all the chapters will be covered of term 2 except our environment, which is not required, and construction, which I think you should be able to do. If you want construction also or something else, ping it and we'll be able to do it in the any other day, maybe Monday. Fine. So these are all theoretical questions. I'm just going to pick my pen up and I'm going to explain something one by one. Cool. So first and the most important point that we have to understand here is electromagnetic induction. Now in general, electromagnetic induction, it means that induction of current, basically an EMF is induced. So induction of EMF, which actually gives nothing but the current I. So current. Okay. So electromagnetic induction is kind of a phenomenon where an induced current is evolved. So a current is induced. It is why it is used in the generation of current also in the AC generators or DC generators. So in AC generators or DC generators, whichever you call, depending upon the split ring or the slip rings, what we get is it has to follow a principle called Fleming's. See the correct definition and all I'll show you in the next slide. I'm just telling you what you have to remember around this, so that if this is asked, you can understand what you also should remember at the same time. So Fleming's right hand rule, okay? Fleming's right hand rule is used for generators. Fleming's left hand rule is used for motors. So left hand is for motors, right hand is for generators. So in case of right hand rule, what happens? There are 3 different, three different axes. So my right hand I'll take. The first finger represents the direction of the magnetic field. The first finger represents the direction of the magnetic field, which is nothing but denoted by B vector. In case you don't know vectors, let it be. Just remember the word B, the letter B. Now magnetic field is represented by the letter B or the first finger. The thumb represents the force or the direction of the motion of the coil, whichever way you want to name it. So force is nothing but it is represented by the thumb. So this is by first finger and this is by thumb. So then the middle finger gives you the direction of the induced current. So induced current. Okay, now what happens whenever there is a change in the magnetic field or the flux attached with the coil, a current is induced in the coil, which is nothing but the electromagnetic induction. An EMF is induced, which in turn results in the creation of current. But for now, you can say that whenever there is a change in the flux attached or linked with a coil. So if I take a coil and if I change the magnetic field or the magnetic field lines passing per unit area, cross-sectional area, or the flux lines are changing, then we call that EMF is induced, which is given by minus n d phi by dt. So this is again very high level. You should not write this for yourself. This is, you can remove. Just to understand that flux is represented by phi. I just made an extra 11th wala thing. Let it go. So the simple thing that you should remember is this. It's a phenomenon of generation of electric current. I told you a current is induced or created or generated by changing the magnetic field. Change in the magnetic field, this is the word that you should remember. Electric current produced by this sometimes is called as induced current, and this potential difference is called induced EMF. This is obviously the case. So now what we have to remember, that the rule that follows or used to find the direction of the induced current is the right hand thumb rule. So, oh sorry, Fleming's right hand rule. Sorry, I slipped my mind. Let's move to the next one. Explain with the help of a label diagram the distribution of the magnetic field due to a current through a circular loop. So you can take a circular loop, put it on a piece of paper or somewhere if you want to see the effect or somewhere. If you wish to, it's okay. And you have to diagram the distribution of magnetic field due to a current through a circular loop. Remember, you are doing a current through a circular loop. So I have explained this once also. I'll explain it again. If I take this, consider this as a circular loop, and the current enters at one point, it's nothing but a small arrangement of linear or line wire, which is nothing but the straight current carrying conductor. So basically any loop is made up of straight lines, and every single straight line, whenever we have already studied this, whenever there is a current passing through a straight conductor, a magnetic field is produced around the conductor. The direction of the magnetic field lines around the conductor is given by the right hand rule, or you can say where you put, or the corkscrew rule. So in which you put the fingers and so that they curl around the wire. The thumb represents the direction of the current. The thumb represents the direction of the current through that wire. The curl of the finger, the way the fingers have been turned around the wire, will give you the direction of the magnetic field around that wire. Now what happens in case of a current carrying circular loop? You see that the field will be like this. To make you understand this again, let's listen carefully. This is the wire. I'm holding it, I'm turning it. So if the current is going up in this side, this is going like this. So basically the field is coming outside and is turning inside here. So outside is north pole, inside is south pole. So this is north facing you, south is going inside. If I keep on changing the direction, because it's a circular wire, not a straight wire, I'm considering it's a straight wire. Every time I curl my fingers, it feels like the field is going like this. It's turning around and closing in. Where it is coming, feeling like it is coming out, is called the north pole, whichever is facing your screen right now, and whichever is towards my side is the south pole. So basically a coil situation is created of the magnetic field. The north pole, one face of this coil behaves as the north pole. The back face behaves as the south pole if the current is entering like this. If the current will enter like this, everything will change. Fine. So for this point, then you can understand. Now let's move to the next one. Why is it that if a current carrying coil has n turns, the field produced at any point is n times? Basically, if I take one single loop of the wire, one single loop, not multiple loops, then the field will be very small because the current is just flowing in one single wire. Now consider there are loops attached to it. There are multiple turns of this wire in the form of circular loop. Then there are multiple north pole, north pole, north pole. Basically small magnet. If I join many small magnets, the net effect will be a very bigger magnet. That's why what you see is north pole, south pole, north pole, south pole, north pole, south pole will become a stronger magnet, and therefore the magnetic field increases, or the magnetic field strength increases actually. Therefore, increasing the number of turns in a coil increases the number of small magnetic field being produced, the summation of which leads to a better magnetic field. And that's why the field also increases n folds. So if you increase one loop to 10 loops, the field also will become 10 times. This is what you have to understand. Fine. Okay. So this is not the right diagram actually. So what I will do, I'll make the right diagram. Okay. Don't consider the solution, by the way. So I'll make the right diagram. Wait. So now, simple way. Let me consider that this is the wire. So the current is flowing through this wire. Of course, you have to take a resistor. Now the current is entering like this and is moving like this in the circular loop. There are small magnetic fields which are being created around the loop of the wire in this way. So hold like this. It feels like if I hold like this, see the current is moving this side. My thumb is towards the direction of the current. I'm holding, it's going inside, it's coming like this. So it's like this, circular, 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 circular. So basically a loop situation is created, and therefore the surface behaves like a North Pole and South Pole, and hence a small magnet. Fine, this is how it should have been. Fine, let's move to the next one. Draw a labeled circuit diagram of a simple electric motor and explain its working. I will not draw it. It will too much of my time. Okay, you can just see this and I'll explain you here. Okay, there should be a horseshoe magnet. Remember, actually it's a horseshoe magnet. So one face is north, the other face is south. The whole loop of this motor is placed inside this. Okay, so now this is where my drawing is like super bad. So I am just keeping like this. Okay, so this is North Pole, this is South Pole. How can North and South be set together? Because they are formed in the horseshoe. So that's why this is like this way. Okay, now you see this is a loop, one like this, right? Now in this case they are joined by the case of split rings, not the slip rings. It's for AC motors. For DC motors it is always split rings. Now what happens, they are connected by a carbon brush. So it's a carbon brush. Why carbon brush? Because it avoids sparking as well as it avoids heat generation. Okay, hey Ashray, good evening. So the carbon brushes are super good because they don't create sparking and therefore the whole system doesn't burn out, and also they are quite good conductors of electricity, so it's better that they connect. Okay, and they connect with the split ring. Now what happens, as the wire moves, as the wire turns around, as it moves around, or we should start with something like, first the current is entering the wire in this way, the current enters in this way, it moves through this phase and comes out. Now whenever a wire is taken and a current is flowing through that wire, a magnetic field is produced around that wire. This is, we all know which rule, right hand rule. Okay, whenever current flows through a wire, a magnetic field is produced around it. Or instead started with this experiment, the first experiment, right? Because of this magnetic field which is produced now and the presence of another magnet outside, the two magnetic fields starts to oppose is, I just wanted to just wait. So the two magnetic fields start to interact. It's like two bar magnets coming closer. They will create a situation called force, a magnetic force. It can be attractive or repulsive, I don't know. But the end result is there, the force will lead to the motion. Now this is why a force is correct. This is why a force is, what do you say? A force is created or produced. To get the direction of the force which is produced on that wire, which will cause that wire to move, we use the left hand Fleming's rule. Okay. So what happens now? Understand. A wire is there and a current is flowing. What is given by which is the direction of the current? The middle finger gives the direction of the current. It's already flowing, it's not induced. Induced is the right hand, left hand is already produced. The first finger gives the direction of the original magnetic field of the magnet that you have used, which is this, in this direction from north to south. Okay, now the direction of the force is given by your thumb, which is acted on the wire that you are considering. Now the most important point is the three are perpendicular to each other. So if in some case the current and the magnetic field are in the same direction, listen carefully, this is important. If the current and the magnetic field are in the same direction, no force is produced. It's zero. You'll understand in mathematics it's sine theta, so sine 0 becomes 0. It's IL cross B. Okay. So what happens now, the part where BC is there and the part where A and D, these are written, this wire will experience zero force, no force. The wire which is perpendicular to the magnetic field of the strong magnet used, the horseshoe magnet, will only experience the force. Now the direction of this force, of course, by this rule. Now the current is flowing in this direction, is going up in this way. Magnetic field is towards north south. The force acting on that part of the wire is below. The force, now in this wire the current is flowing down, so the current is flowing down, so it is coming like this. Magnetic field is towards this side, my thumb is at the top, so the force is at the top. Now this means that, this simply means that the loop will start to rotate in this way. Now this is where you see the motion will happen and this will become a motor. These DC motors you must have seen in the toy cars or in some other actuator motors where you play with DC batteries. Okay. So now these DC motors will create, this coil will rotate, right? Now the coil rotation, the current changes in half of the rotation. This is important again. This is very important. Now what happens, because of the split ring, the AB branch jumps towards the CD side. So the current in the AB branch is halfway is towards up, while when it turns and touches to the other side, which is nothing but this Y point, in that case the current is towards down. So half case AB is here in the upward current motion and in this downward motion. Because of this change in the direction of the force or the current in half of the rotation created by this device in such a way, the split rings also work as commutator, and therefore this machine can move continuously in one direction. Otherwise it will just flip, which should not happen. Okay. So principle is, whenever that a rectangular coil or any coil is placed in a magnetic field and a current is passed, a force acts on the coil which rotates continuously. Of course we saw it. Okay, I already told you this, full working I already told you, explained you just have to copy paste, nothing else. There was one question asked, what is the difference between a commercial and a normal and a home motor? See, commercial motors you have to use strong magnets. The problem with the permanent magnets available in nature is that their magnetic strength is fixed. In order to increase the magnetic field strength, you have to buy bigger magnets. You cannot pack this magnet in a small space, correct? So you cannot use them in industry. The devices will start to become heavy. They will become heavier. So instead of having a permanent magnet, an electromagnet is used. What is an electromagnet? An electromagnet is nothing but a magnet created by the passage of current. We know that whenever a coil carrying current is there, it produces a magnetic field around it, right? So a current carrying coil produces a magnetic field around it. Basically it is a magnet. We start with the same question. It's a magnet only. Now since it is a magnet produced or created by the passage of current, so because electron or current is creating a magnet, it's an electromagnet. So instead of buying a bigger magnet, we get a small coil, pass heavy current in it, it becomes a magnet. Now this electromagnetic coil, there is inside a coil now. So this behaves as a north and south of a horseshoe, north south of horseshoe. So this is why commercial have this. You open your fan, you'll see there is a coil around the body. That is nothing but an electromagnet. It's an artificial metal or magnet, correct? So then what happens? Inside it there is the rotator coil, which is the coil of that, the ABCD wala part, and it has also multiple loop, of course. So what happens now? This coil now experiences a force because the current is also passed in it. Of course they have to be separately, otherwise same current and all these problems. But yeah, in the end these two magnetic field interacts, a force is created, and then the rotation and everything the same. Now electromagnet is used, then is number of turns in the coil are less. In your electric motor commercial, the coil's turns are more because of heavy strength and heavy motor requirement. There is no iron core. Iron core increases the permeability. There is a term called permeability. Okay. So permeability is nothing but the simplification, or what do you say, the passage of the magnetic field becomes super fluid when an iron core is produced, an iron core is present. Okay. Otherwise through air it will take a lot of wastage of energy of magnetic field, but otherwise the soft iron core gives a very smooth passage. Just understand in a layman's word. Later on you will read it about in class 11th. Okay, fine. Let's move to the next one. What is the role of fuse? Everyone knows it. बेटा सैंपल पेपर एक्स्ट्रा ही शुरू हो रहे हैं, आई थिंक मंडे ट्यूसडे से, ठीक है श्री, मंडे या ट्यूसडे से, आई एम नॉट श्योर बट डिटेल आ जाएगी, अभी हम पोस्ट कर देंगे चैनल पे, ठीक है, मेरे ख्याल से मंडे ही है, ठीक है। सो फ्यूज क्या होता है? वी ऑल नो दैट फ्यूज is a device which prevents an appliance from getting burnt, destroyed or affect in a bad way, right? So what happens? The fuse itself blows away to safeguard the device or the appliance. So you always see in your main circuit boards also there is a fuse, so that your whole home supply is your whole home supply is not affected. Fine. Okay. Give me 1 minute, beta. So now let us understand another thing, okay? In this case, what happens? Let's say you have got, what do you say, a full wire coming into your home, right? You see there's a big fuse. That big fuse actually prevents the whole home. Then inside, when you go inside in some boards also, they put one more fuse. That is another safeguard, because then that fuse will help in that sectional area only. Then you see in the other what do you say, other devices, there are like certain like heavy appliances like geyser or something. There's another fuse. That fuse is just specifically preventing the geyser only. It's not preventing the whole home. But every fuse has this fundamental thing that it has got a fuse wire. Now this fuse wire is a combination, okay, okay, of lead and tin. Fine, it's an alloy. Why you cannot use copper? Because copper is a super good conductor of electricity. The moment high amount of even flows through it, it will not burn or melt. It will just be happy. It will just glow a little. The problem is we want to break the wire so that the rest of the circuit is not affected. So this wire should blow off. And there is no problem of the whatever current is flowing inside the device. So this can be only prevented. This can be only prevented if this wire has low melting point, and it should be resistive. It should not be superconductor. Then it will allow. So high resistivity. So if this wire has a low melting point, it will melt. If it is a high resistivity, then the current will produce some heat and it can melt extra. But the resistivity is of course a little setting factor. So this way a fuse is used, okay. Then there is a rating of the fuse. This is what I was talking about. You cannot have any rating of the fuse. You want to safeguard a 5 ampere device. You cannot put a fuse which works or blows off at 6 amperes or 7 amperes. 6 ampere is okay, it will fine, but not 7 ampere or 8 ampere. Then what will happen? 5 ampere will flow and blow off this device, the device which is not allowed to work over 5 ampere. So, and you cannot put a 3 ampere fuse with a 5 ampere device. Again, because at 3 ampere it will blow, its working current is 5 ampere. Why are you blowing it off at 3? It will never work then. Every time the fuse will blow off. You will replace the fuse, 3 ampere blow off. Because the device needs 5 ampere. You cannot put a 10 ampere fuse. If you put a 10 ampere fuse, the fuse will not blow, but your device will blow. Don't want that to happen, right? So what do you want is a rating of a fuse is decided based on the device that you're going to use. That's why your home fuse is so big, because your whole home rating is very high. But your device, which is inside a let's say appliance, let's say an iron or something, is small, is compared to very thin wire, because that device should blow off at a certain 2 ampere, 3 ampere current or a 5 ampere current. You got the point? Yeah. So, and the ratio of course is 75. Basically it is 3:1. Okay. Fine. Okay. Everything is written. I have told you low melting. So the melting point should not be very high, and it should. So the rating of course decide based on that. Okay. Last question. How will the magnetic field produce at a point due to a current carrying conductor coil changes? I told you starting question. A current carrying wire produces a magnetic field around it, or instead jai ho. Same wire, I turn it, make it circular, elliptical, helical, whatever, doesn't matter. It will always produce a magnetic field around it. Current is flowing किसी wire से, उसको तोड़ो, मोड़ो, जोड़ो. Do anything. The magnetic field will always produce. Thus the shape of the magnetic field will keep on changing, and accordingly it will be useful in a separate case. Now, what happens if I increase the current? Of course, if you pass more current, more magnetic field strength will be produced. So directly proportional. What will happen if I reverse the direction of current through the coil? The magnetic field will reverse. It's behaving like a north-south, north-south. The current has reversed, the magnetic field will reverse. and therefore south north south north. So it will reverse. Increase the number of turns, it will increase or become more. Because one loop छोटा मैग्नेट, दो लूप दो छोटा मैग्नेट, तीन लूप तीन छोटा, 100 लूप 100 छोटा मैग्नेट, 100 छोटा मैग्नेट बराबर एक बड़ा मैग्नेट. So this will happen, okay? Just remember this, okay? I hope everyone has got everything. I wanted to actually have this tomorrow, but I am taking a break kind of thing, so I wanted this to shift one time. Okay? That's why I took it today only. Rest class will happen tomorrow. No rush, no issues. Okay? I hope Ashray, and don't worry about it, Ashray, we will start sample paper now because now is the right time also. Yes, I know, Harish sir. Okay, okay. सब 10th के बच्चे हो तो समर कोर्स में तो आओगे नहीं. मैं एक काम कह रहा हूं, समर कोर्स में आके एनरोल कर लो. ठीक है. सो ऑल ऑफ यू डू वन थिंग. समर कोर्स इज स्टार्टिंग फ्रॉम 25 अप्रैल. तुम लोग 10th वाले बच्चे, राइट? और वो स्टार्ट 25 से हो रहा है. अब हमको करना ही था समर, ये तुम्हारा चला गया, मैं क्या करूं है. So what will happen now? It will start in April, it will end in some May, somewhere like some other course will end on 12th May, not 12th, so 20th May, 25th May. So what we will do this thing that you go and enroll for the course. If you have not bought a paid subscription, ज़्यादा महंगा भी नहीं है, बहुत सस्ता है, बहुत ही सस्ता है. Just buy it, okay? So somewhat 7,000 for a year, and you get science, math, everything else, and you get 10,000 rupees. You get coding also. So take it. Now, so see what happens. I don't know the exact price, but it will be around this. थोड़ा ज़्यादा हो तो चिल्लाना मत. So go and enroll for, if you want photography, graphic designing, Photoshop वाला एकदम बढ़िया. And if you want music, if you need to, or if you have interest in classical Indian music, good राग वगैरह के बारे में, robotics Arduino से करेंगे, ठीक है. और जिलानी सर everyone knows, तो उसमें हम कर रहे हैं, वेबसाइट बनाएंगे अब पूरी वर्डप्रेस से, and we will also make games Roblox से. बड़ा मजेदार है Roblox सर्च करना, बहुत मजा आएगी. ये 6 कोर्स हैं, अभी से जाओ एनरोल कर लो, ठीक है. और मतलब बढ़िया कोर्स हैं, एकदम धाकड़ वाले कोर्स हैं, ठीक है. सो गो एंड एनरोल. इसमें से 6 में से जो पसंद आए, कोई फर्क नहीं पड़ता, एक ही बार देना है पैसा. अरे बहुत सही अश्रई, ठीक है. मतलब फिर तो सही है, मैं तो ज्यादा ही बोल गया था, मैं सोचा थोड़ा और ज्यादा होगा, और क्या सस्ता ही पाए हो आप. तो ये दिस प्राइसेस विल गो अप लेटर ऑन. तो अभी मैं कह रहा हूं एनरोल कर लो. क्लासेस अगर नहीं भी देखोगे, एनरोल्ड रहोगे ना, तो रिकॉर्डिंग देख सकते हो फ्यूचर में, ठीक है. तो अभी कुछ फर्क नहीं पड़ता, जाके अभी कर लो, रिकॉर्डिंग वगैरह देख लेना, फिर एक दोबारा से री कोर्स चलवा देंगे. बोलोगे तो एक फिर से एक रिपीट मार देंगे किसी कोर्स का, है कि नहीं है. जहां वहां रहा. रोब्लॉक्स इज वन. यस सार्थक, करेक्ट. तो मेरे ख्याल से कर लेना चाहिए. और साइंस मैथ वाले के लिए तो फिर हम बाद में बैच शुरू करेंगे 11th का, जून में करेंगे. पेपर खत्म हो जाने दो, फिर 11th में जेई नीट का बैच शुरू करते हैं, बढ़िया वाला एकदम, है ना. टॉप आईआईटीएंस ला रहे हैं सारे, ये सब छोड़ो, सारे टॉप आईआईटीएंस, आईआईटी दिल्ली से सब पढ़े हुए, ठीक है. एकदम बढ़िया वाला क्लास. तो और हिंदी में करेंगे उसको, ठीक है, मस्त एकदम हिंदी में, इजी रखेंगे, बढ़िया रखेंगे. कंटेंट वंटेंट की चिंता मत करना. ये 6 में से फोटोग्राफी का अगर शौक हो तो कर लेना, बड़ा बढ़िया सा है, ठीक है. सान्या मैम है, उनका बड़ा अच्छा प्रोफाइल है, स्विगी वगैरह के लिए काम किया उन्होंने, ठीक है. तो मतलब एकदम मैक्रो फोटोग्राफी उनको अच्छी से वाली आती है. ग्राफिक डिजाइन भी वही सिखाएंगी, पता नहीं कब से कर रही है, जब से तुम्हारी उम्र की थी तब से कर रही है, 10 साल हो गए उनको करते हुए, ठीक है. ग्राफिक डिजाइनिंग वगैरह तो वो तो फायदा ही देगा. म्यूजिक कैलिफोर्निया में वो उनका खुद का गंधर्व म्यूजिक करके आर्ट का स्कूल चलता है, वो पढ़ाते हैं, ठीक है. तो वो करेंगे. आदित्य शर्मा सर है, बिल्कुल अल्टीमेट इफेक्ट है, पीएचडी किया उन्होंने म्यूजिक में, ऐसे कोई नहीं है, ठीक है, एकदम अल्टीमेट वाला है. और रोबोटिक्स करेंगे, मधुकर सर है, बहुत ही बढ़िया. 10 साल से वो इंटरनेशनल बच्चे उनके ओलंपियाड निकाले रोबोटिक्स का, इंटरनेशनली. नेशनल तो छोड़ दो, इंटरनेशनल निकाले. तो एक बार वो कर लेना. वेबसाइट तो जिलानी सर को तो सभी जानते हैं, जिलानी सर आएंगे, वेबसाइट बनाएंगे वर्डप्रेस से. कौन सा बनाएंगे ये भी तो पता होना चाहिए. बिजनेस बनाएंगे, ई कॉमर्स, सामान बेच सकते हो, एंटरप्रेन्योर बन सकते हो. और एक बनाएंगे तुम्हारा खुद का पोर्टफोलियो, कैसे बनाते हैं, अपने बारे में तो होना चाहिए ना. तो एक इंट्रो वाला, सिंपल वाला भी बढ़िया वाला, और एक बिजनेस वाला, ठीक है. और भी पता नहीं क्या क्या बनाएंगे, पूछना उनसे क्लास में जाके. गेम्स तो रोब्लॉक्स से बनाओगे, पब्लिश कर देना, ठीक है. अगर तुम्हारे भाई लोग हो 6 to 9th में, बता दो. 11th 12th में बड़े भाई हो तो उनको बता दो, जिसको अवेलेबल हो बता दो, छोटे बच्चों उनको भी बता दो, सब सीख लेंगे. फोटोग्राफी तो आजकल सब सीख जाते हैं, नहीं. चलो, तो नेक्स्ट क्लास में मिलेंगे. वी विल नेक्स्ट क्लास इसकी 5 मोस्ट इंपॉर्टेंट. याद रखो, इन्हीं 5 में से हम फिर मिलेंगे पेपर के बाद. We will all sit down and see what all questions we have solved, 5 into what 10-12 classes. Those 50-60 questions should reflect at least for 50-60% in your exam. Done. Okay, so we'll meet you in the next class. Tab tak ke liye bye bye and good night.